Good afternoon, YouTube. I am making an aluminum heatsink here, and this is going to be for my SBMS-120. This is from ElectroDacus, the solar battery management system. So this is a 120 amp charge controller, and one of the things that it's set up for is you've got these two holes here that pass through the front, and you can actually screw this thing to a heat sink. And I was looking around. I had a heat sink that was most of this size, but it wasn't quite wide enough to line up with those holes. But I was digging through my pile of scrap aluminum that I picked up from the metal yard. They have just random cuts of metal, and I found this piece. It was 1.5 inches thick, and look at that. I mean, it's the exact width, and it's within probably a couple millimeters of being the exact height. And I can't remember what I purchased this for, and I thought heatsink. So what I did, I left these solid pieces at the end to pick up the screw holes, because you have to put some threaded holes so that you can screw this thing down. This is, of course, the back side of the heatsink. It'll be flipped over, and then the holes for mounting the charge controller will be threaded into this thick section on each edge. And then I'll probably put 4 holes, 2 in each corner, so that I can screw the heatsink onto a surface. I think I left roughly 3/4 inch on each side, and then I went about every 1/2 inch and drew a line. And so I used the bandsaw to cut a saw curve down, and I marked about 1 inch deep here, so I leave a 1/2 inch at the bottom that's not finned, and then I run my grooves down about 1 inch. Of course, as the bandsaw comes down, this edge over here goes the full 1 inch deep, but over here it doesn't quite get to the mark, so it's not quite full depth. And then I put a 1/4 inch 6mm milling cutter in the mill, and it takes me several passes. I'll come across on the first pass and do about 1/4 inch. That one works okay because it can throw the chips out. And then on subsequent passes, I do about 100 thousandths going back, and then I clean out the groove, and then I can do about 150 this way, another 100 that way, and I repeat. This is a little cutting fluid. So let's see what this looks like here. Yeah, and then I like to stop and check the cutter teeth here, because every once in a while the aluminum will gum up and fill the flutes here. So I just stop and check that. So what I can do now is I can drop it down about 100 thousandths, give it another shot there, and we'll go back. Now you can see the groove is pretty well filled up with chips, so I've got to scrape those off, and then I use a little round file to get in there and pull the chips out. But I think having that little saw cut in there, if you can see that down in the groove, that saw cut helps, I think, helps the cutter a little bit, gives it a little bit of clearance as you're going through. And this cutter doesn't quite have flutes all the way up. I think it's got about 3/4 inch of flutes. When I get done, I'll be right up to the collet. And at the end, you got to kind of slow down because the chips start building up in there. 4 or 5 back and forth passes to clear that out. I'll come back and show you what that looks like when I finish. Okay, we've got all the grooves. We've got 2, 4, 6, 8, 10, 11 grooves that I cut in there, so there's that many fins. And then I have my chamfering bit in there. I'm going to try running that up and down each of the grooves and then around the outside just to knock off all these sharp corners. I went down till the cutter touched and went down about 50 thousandths of an inch. So let's see what that looks like. Yeah, I think that's nice. Gets rid of all the sharp edges and I don't have to get in there with a deburring tool, so I'm just going to run down all the grooves and then I'll run around the outside at about the same depth of cut. It's for a hole chamfering, but it works good for taking the edge off of a straight thing too. Okay, there we go. That's a lot of cutting. I just lost one cutter in the process. This was the second one I used. First one, it had like over an inch long and it broke right at the top of the flute, so I figured actually this slightly shorter one, which you can see doesn't quite go the depth of the cut there. I think this one was a little stronger. You just have to make sure the flutes don't get gummed up with metal there. If they do, you got to stop and clean out all the flutes. And then what I did was wire brushed it after I cleaned the metal out, and then warmed this up a little bit with a torch and ran it in some paraffin wax to give it a little bit of a coating, and then applied WD-40 every second pass through there. And this one, after I started doing that, didn't jam up for probably 7 or 8 grooves, so that was pretty good. Yeah, there's my 2 little holes. I got to drill and tap these holes to put the charge controller, mount it down, and then I'll probably drill 4 holes there to mount this heatsink down. And then I guess I need to run my chamfering bit down here too. Do that on the edge because these are a little bit rough. But yeah, I think that ought to work. That's a big hunk of metal there. But yeah, I mean, I didn't have to do any cutting at all. This is just as I got it from the metal yard. And for this material, you just pay by the pound. It's all scraps of metal that other places have turned in for recycling. So I'm using that. So yeah, I'll get that cleaned up, get the holes drilled and tapped, and then maybe I'll bring you back and show you what it looks like with the charge controller attached.